Allowing for an operation to be cancelled is a good idea. When it comes to parallel for each, and parallel invoke, they all support cancellation out of the box. When it comes to cancellation, these parallel operations do behave slightly different from how the break and stop functionality works. To explore this, let's introduce the cancellation token source. Once we've got this cancellation token source created, we can tell it to automatically cancel after a certain amount of time. To do that, you can call the method cancelAfter with a given number of milliseconds. If you pass 2000, that means it will signal for cancellation after 2 seconds. There's also a constructor overload that lets you pass a time span, which determines the time before automatically signaling for cancellation. I prefer to use the method cancelAfter for this example, as it's much clearer what's going to happen. The cancellation token source creates a cancellation token. To pass the cancellation token, you first need to create the parallel options. These options, as you've seen earlier, exposes ways to configure the parallel execution. Set the cancellation token to the token created by the cancellation token source. Also, set the max degree of parallelism to 1, just to easier understand what's going to happen. With this, you're now ready to use the parallel options with the parallel for loop. Pass it as the third parameter, and your parallel for loop is now configured to monitor for cancellation, as well as only running one thread at a time. Inside the loop body, you can call the method compute and add the result to the total variable. You can choose if you'd like to use the interlocked class, or if you want to use a lock object that we've explored earlier. I'm going to use the interlocked class to keep the code to a minimum and accept that I must cast this to an integer, which means I'm certainly going to lose a little bit of data. But that's fine for now. What do you think is going to happen when we run the application? Will the parallel for loop automatically cancel? How much will it have increased the totals variable? Let's run the application to find out. After a little while, an operation cancelled exception was thrown. This may come as a surprise, but as previously discussed, the parallel operations will monitor for exceptions. And in this case, it also monitors for cancellation. When it detects a cancellation, it will throw this exception. We still don't know how many of the iterations it executed. It did seem to throw an exception rather quickly, so I'm pretty sure it didn't run through all the iterations. If you wrap the parallel for call in a try and catch block, we can catch the operation cancelled exception and write something to the console when that occurs. Then at the end of the method, make sure that you also print the result of the totals variable. Run the application again. This time, the result will be a little bit different. And there are two things that I find rather interesting. First, we can see that the application completed executing after approximately 2 seconds, which is, in fact, exactly the amount of time we told the cancellation token source to cancel after. Second, the result of the totals variable is not nearly the same value as we've previously gotten when running the application. Therefore, we can assume that when the cancellation was requested, no further iterations were started. This is different from what you might have expected. As we saw previously, when exceptions were thrown inside the iterations, the subsequent iterations weren't automatically cancelled. However, in this case, they were. This is because it's built on top of the task parallel library. And it makes sense that no new tasks are started because the cancellation token is set to cancelled. An important thing to remember is that it won't stop the execution of already started operations. If that's important, you will have to monitor the cancellation token inside the iteration and handle that properly, just like with a normal task. This is good for situations where you might have more than one expensive operation, and a cancellation could have been requested between the two operations. You then have the option to check is cancellation requested, or throw an exception. Personally, I always go for checking if the cancellation is requested. It's important to remember that it won't start any new operations when a cancellation is requested. And depending on who runs the application, 2 seconds might mean that it completes the entire operation, or it might mean that it only completed one iteration. With that being said, this is a great addition, and in most cases, when a cancellation is requested, the data that has been processed so far is not of interest. Most of the time, the result of a parallel operation is only interesting if the entire operation ran to completion. This allows you to introduce the cancellation token and the cancellation token source with the parallel operations in the task parallel library.